Hi guys. This week we're going to start our global change unit, and the first section that we're going to focus on is the air and air pollution. Today we're going to talk about the structure of air, what's in it, what layers are there, um, and how does it work. Tomorrow we'll start to get into air pollution, the types of air pollution and the effects of those air pollutants. On Wednesday we're going to celebrate Earth Day. Then on Thursday, we're going to talk about acid rain, what causes it and the impacts it has. And on Friday, we're going to talk about the holes in the ozone layer, right? So to start off, we're going to go right to look at the structure of the atmosphere. So as you guys know, the atmosphere is the air. All right, it's everything that surrounds the Earth, the layer of air molecules that surround the Earth. Air is made up of mostly three main things. The biggest one, that's about 78% of the atmosphere, is nitrogen, just plain old N2 floating around. You can't see it, but it's in between you and your computer right now. All right. Then you have oxygen. All right. Oxygen is about 21% of all of the air, right, in the atmosphere. And then you have a couple of other things that make up a little bit. There's a little bit of carbon dioxide in the atmosphere, right? There's a little bit of water vapor in the air. And then there's a couple things that make up very minute parts of the air. Most of the air molecules are located in the bottom layer because gravity is going to push them down. This is why it's a lot easier to go for a run here than it was for me in the mountains of California. All right, mountains of California, the oxygen molecules are actually further spread out, and so it's harder to breathe. Okay, we call that the push of the air molecules from gravity. We call it air pressure. And 99% of the total mass of the atmosphere is below 32 kilometers, or about 20 miles. Right here is the diagram. It looks a little bit crazy as you first look at it. So let's look at all the different things. It's really a diagram showing us the temperature of each layer. On one side, it shows us the altitude, and on the other side, it shows us the pressure. They can do this because the altitude and the pressure are on the same scale. So as you go up, the pressure changes. Okay. So your temperature of the troposphere, this is obviously in Celsius, but as you go up, the temperature is going to decrease, meaning that it's going to be warmer, closer to the Earth, right? And then the temperature will go down in the stratosphere, go back up in the stratosphere, go back down in the mesosphere, and then continue to climb as you go up the thermosphere. Okay. In the troposphere is the layer that we live in, and it's where all your weather occurs. That's why when you're in an airplane and you go above the clouds, you're actually leaving the troposphere. So it extends up to 12 kilometers, or 7.5 miles almost. Contains 75% of the gases in the atmosphere, and as the height increases, the temperature decreases. All right, so we saw that as the height increases, the temperature decreases. And now we're going to talk about the stratosphere. The stratosphere is one of the more important layers because it contains the ozone layer. Right? It goes from 12 to 50 kilometers, and it contains the ozone layer. Most of the ozone layer is found in between 6 and 10 miles. Ozone is a special chemical. It's made up of O3. So instead of O2, which is the normal oxygen that we breathe, it's changed its structure and now it's O3. And it forms a layer in the stratosphere that actually blocks a lot of the UV radiation that comes to Earth. If the ozone layer didn't exist, we would get a lot more UV radiation. So incidence of skin cancer would go up, and actually plants would have a hard time doing photosynthesis. We're going to talk more about that on Friday. But this layer is located in the stratosphere. All right, so it's in between 6 to 10 miles. So it's going to be right in here. Okay. As you go up, you get to the mesosphere, and now you're going to see the temperature is going to start to decrease again. Okay, it gets very cold up here. If you watch the movie Aeronauts, it's a really cute movie. I think that you guys would enjoy it, actually. But it does talk about how they went up in the air balloons and found out the different layers. right? They were trying to figure out weather. And so they went up into an air balloon and they found a bunch of different layers of the atmosphere. Mesosphere goes from 50 to 80 kilometers or 31 to 50 miles. It's the coldest region of the atmosphere, and this layer protects the Earth from meteoroids. They burn up in this area. See, the meteoroids can go right through the thermosphere, which is the layer on top of the mesosphere, can go right through that. And they can go right through that because the air molecules are very spread out. In the mesosphere, the air molecules begin to get a little bit denser. So because of that, they burn up there. Oh, wait, I want to show you guys this. All right, so there's your meteoroid, and it burns up. And now it's a meteor because it hits the Earth. So meteors are going to go through the atmosphere and be able to hit it, right? And then when it's done, it's a meteorite. So right now it's a meteoroid. It's going to burn up. Most of them are small enough that they burn in the atmosphere. All right, not all of them, but most of them are small enough to burn in the atmosphere. Okay, so now we're going to go and look at the thermosphere. Notice that in the thermosphere, you're going to end up with, it's going to start to get a lot. I keep going too far. All right, so thermosphere is the highest layer. It goes from 80 kilometers and up. There is very thin. The temperature is very high in this layer because UV radiation is turned into heat. Temperatures can often reach 2,000 degrees Celsius. Okay, and that brings us to our last slide here, guys.